Hi, everybody, and welcome to our latest segment of Data on the Edge. I'm really happy to introduce Mohammed Musa, CEO and founder of Deepen AI, a leading LiDAR tool that we partner with, and Mo is a good friend. He's also very, very knowledgeable in the field of LiDAR. And Mo, let's jump right in. Nice to meet you. Thanks for coming onto the show.
Yeah, thanks, Jay. Excited to be here.
Great. So why don't you give us the elevator pitch for what Deepen does in LiDAR?
Yeah, definitely. So yeah, hi everyone. I'm Mohammed Musa, founder and CEO at Deepen. We started about 5 years ago. Specifically, actually, our first product was in LiDAR sensor fusion. The goal of the company was to build safety tools for multi-sensor systems. And it turned out that one of the most important aspects of safety is validating real data. So we built a full annotation suite for sensor fusion, LiDAR included, obviously. And then we started expanding after that to calibration of multi-sensors. And now we also have a safety validation suite called SafetyPool.ai that has a database of scenarios to verify the safety of ADAS and autonomous vehicles.
Great. So that's a pretty tech dense description. When we look at a use case, so when you have a self-driving car on the road and it's equipped with LiDAR sensors as well as traditional cameras, can you describe where you sit in the whole ML data ops cycle for this car at that point?
Yeah, definitely. So with our calibration suite, that's pre-data collection. So you need to ensure that you're collecting the right data at the beginning. So customers use our calibration software to make sure that the data is correct in both space and time across the different sensors. So like, let's say a typical autonomous vehicle has maybe 12 cameras looking 360-degree around the vehicle. Maybe they have 4 or 3 LiDARs that also have 360-degree coverage. Maybe one that is like, the Waymo big LiDAR on top that has a 360-degree view. And then there is a couple of smaller LiDARs that look at specific areas for short range and long range and maybe front facing and one in the back and so on. So that's multiple LiDARs. And then you have 12 radars as well that are also collecting data. And then for typical driver assistance for like assisted parking, you have maybe 24 sonar sensors, ultrasonic sensors that are also collecting data. So each one of these sensors requires calibration between the sensor and the other sensors and between the sensor and the vehicle. So we call it sensor to sensor calibration, and there is sensor to system calibration that we do. So that's the pre-data collection stage. Then during data collection, we have some algorithms that customers can use in real time to detect major issues in calibration. So for example, if there was a small accident that switched the location of the camera or maybe the frame rate of the LiDAR, you need to be able to detect that and raise that as a flag. It might be safety critical, it may not be. If it can be corrected, we say, yeah, we can correct this issue. So you can proceed with data collection and you can keep running the same algorithms for collision avoidance, for adaptive cruise control and similar other advanced functionalities in full autonomy even. So that's during the data collection process itself. And then post-data collection for validation and training, we have our annotation tools that users like iMerit and others, even the customer themselves, can use the tool to visualize the data, to annotate at very, very high accuracy down to the point. So you can have 200, 300 million points of LiDAR data over time that you need to understand at very, very like granular detail. Where's the road, where's the sidewalk, where is the pedestrian, the traffic light, and track that across all of the different sensors. So like, how does this look in LiDAR 1? How does it look in LiDAR 2? How does it look in camera 1, camera 2, radar 2, et cetera, et cetera. And within our tools, you can do all of that simultaneously. So track and segment objects and static objects over time and space to validate the data, to make sure that you're detecting what you're supposed to be detecting, you're tracking what you think you're tracking, and you can use that data to train the AI models. So that's called ground truthing. And then you can also use it for validation to see how good your system is and verify if you have any gaps in your detection stack or segmentation stack or prediction stack or segment, like the different perception as well as higher order AI that enables autonomy or driver assistance.
Cool. I think what you described with these multiple streams of complex data, and then I think the inherent complexity of LiDAR point clouds in themselves. That's one of the reasons why we rate LiDAR files and LiDAR sequences as some of the most complex work we do in data ops, both from a complexity of data point of view, as well as from a bandwidth and density of data point of view. Typically, those are our most performant machines that have to process that data as well. So as far as the human expertise goes, we find a lot more nuance, a lot more complexity, a lot more depth in the LiDAR annotation process than we do in many other processes. So that takes us to our favorite topic at iMerit, edge cases. Can you think of some good edge cases that might have come up and how they've been resolved? Maybe jump into the tool real quick and give us some examples of why this complex sort of multi-sensor fusion can get into issues and what sort of nuance gets involved, how that process works.
Yeah, definitely. Let me share my screen and show a quick, this will make a lot of what I was describing earlier come to life. Here's a typical, about 200 frames of LiDAR data combined in our viewer. And our tools, we invested a lot of time to enable rendering this kind of density at this accuracy. And if we look at the different sensors, so like let's look at the camera, for example, and we can project the LiDAR point clouds into the camera view. Just to set the scene, this data is from the Waymo public data set that Waymo published, and we just took the data and annotated it ourselves using our software. And what you can see here is this scene in LiDAR view. The scene in the LiDAR view in 3D is the full sequence of the full 200 frames. There is about 60 or 70 million points that are loaded at the same time. And within this scene, we can dig deep and see where are the pedestrians in the entire scene. And you can see there are a few pedestrians that are walking. So this trail of points is actually a person walking over time. And if I show you the vehicles, maybe it will make more sense. This long trail of points is a single vehicle that is driving for all of these 10 seconds or 15 seconds that the data is showing. And you see some parked vehicles like this one here, and this one here is a parked vehicle. And then once we, let's maybe disable the dynamic layer and show some of the static layer. So I'll disable the vehicles here. Here's the road, here's the sidewalk. Let's look at the buildings. And with LiDAR specifically, this is a lot of edge cases can arise from random points. So let's disable the buildings here and just show you the complexity of vegetation. Lot of vegetation. So when you have 3-4 LiDAR sensors collecting tons of photons that are reflecting back from these vegetations, there is a lot of noise, there is a lot of like a false positives that you're getting, and you need to distinguish between what's a real object versus noise. And we actually, in our tool, we enable the labelers with a good mix of AI and human in the loop working together. to identify what we call ghost points. So if I enable ghost points, let me disable vegetation for a second, and also disable the road so you can see, and disable the sidewalk. And then I will make these points a little bit bigger so we can see them in here. So make them a little bit bigger. All of these points are ghost, so noisy. This is noisy data. The real-time algorithms need to quickly be able to identify that those are noisy points, they're not real. Because imagine if you were looking at these noisy points and you thought there is something that is about to hit you, then your vehicle will never move. It'll be stopping the whole time because it thinks there are objects blocking it. So that's a critical issue. Ultimately, for autonomy to launch, we want it to be economically productive and safe. Like, you cannot be just safe and not be economically adding value, because then, what's the point of $1 million car that doesn't move? But also, what's the point of $1 million car that kills people along the way? So you have to kind of have this really balanced trade-off between safety and productivity or efficiency. And as a company, actually, our mission statement is to make the world safer and more productive faster. So like everything we do in terms of our tooling is around that balance between safety and productivity to the point where things can actually run. And with the annotation tool, you can figure out where are the correct points, where's the humans, where's the vehicles, are there like any cyclists in this scene? There is no cyclists. Let's see at the ground. Here's the ground point. So for things like last mile delivery robots that deliver meals, or they go on the sidewalk, mostly the ground is a lot more important than the road, because they're not going to be on the road that much. And obviously, sometimes you may get things that you're not even aware of. So we call that new class in here. Luckily, in this scene, we've segmented everything, so there are no new classes. But how do you deal with uncertainty, or like things that you've never seen before? And can you have some sort of, so I'm getting into different types of edge cases, right? There's edge cases around just bad sensor data. There is edge cases around things that you've never seen before. And there is edge cases around things that you have seen and that but it's configured in a way that you've never predicted. For example, construction area, construction zone. There are a bunch of cones, there are some workers, maybe if it's an accident, there is a bunch of ambulances and fire trucks. And how do you navigate? There are cops or traffic controllers that are telling you to move into a certain direction. So the car needs to be able to understand and even validate that those actors are real. You don't want anyone who's dressed like a cop to be telling the autonomous vehicle to go and park. Maybe they're not a real cop. So is there a way to kind of collect the signals and try to figure out, is this actually a real scene, and what the car is supposed to do? I think this edge case topic, we can go on forever, especially when it gets to security and cyber security and things like that. But if we just focus on the vision perspective, there is the detection. Is there stuff in front of me? And then there is classification. What am I looking at? And then there's segmentation. Where does the human end and the car start? Where does the road end and the sidewalk start? And then there is prediction. So you want to understand the trajectory of the movement of these objects. And within that, there are things that are occluded and things that are fully visible. For the things that are occluded, how do I deal with them? Do I know that they exist, or are they fully occluded? So if there's a pedestrian walking on an urban area right behind a truck, where I don't even know the pedestrian is there, and I haven't seen it in any of my sensors, how do I deal with that? What kind of speed am I allowed to run so that I can make a safe stop? And so that's another area. And I guess I can go on forever. So I want to, JB, kind of, what else would you like to dig into?
No, this is an absolute goldmine. I like the way you've kind of broken out the edge cases into almost like use cases of edge cases, and it makes complete sense. And I think given the dynamic environments, it's impossible to write instructions or provide examples of every conceivable scenario that might come across on the street. And I think that kind of underscores, I think, a little bit of how we work together to help a customer at iMerit and Deepen. Oftentimes, it's not what we know, but what everyone doesn't know until they come across it, and then how to handle that, which kind of needs to be defined better. I just love this this point that you made, that the car would be completely paralyzed if it had to consider every input as a legitimate input. The removal of noise is one piece. The creation of new classes that you haven't seen before is another piece, and being able to communicate that back to the data engineers and saying, hey, we came across something that you should probably start collecting more data and train your model on. So I think this was a pretty good exposition of different types of edge cases that that can occur. I think what has been your experience in terms of the complexity of these projects with customers, and the way that the common misconceptions or the common challenges that typically Deepen and iMerit have to address together when getting into projects like this?
Yeah, with 3D data and sensor fusion in general, I think it's relatively a new field for the safety applications. Like for automotive specifically, actually, there hasn't been a lot of LiDAR usage before. Maybe in other cases like mapping or geospatial, they have more experience with LiDARs and what they care about, like what aspects of the data they care about. But in autonomy, there are no standards. It's still kind of, actually, even for labeling in general, there was no standard up to last week when we launched open label with ASAM in Europe. So it's been kind of Wild West in the sense of a lot of companies are developing their own LiDARs. Some other companies are now starting to rely on external vendors that now have become public companies. So LiDARs are now real. They're here to stay. I think the arguments around, several very strongly opinionated public figures saying like, LiDARs are not needed and so on. There are cases where they're truly not needed, and there are cases where they're absolutely needed. And I think kind of the use cases across different industries are starting to emerge now, where we see in agriculture, in manufacturing, in even in security and monitoring, these sensors are now being deployed and are able to collect data that the cameras by themselves are not able to handle. And the bottlenecks that we typically see with iMerit when we go to a customer together are around, is the data being collected, is it good quality? Then what do we annotate, or what do we consider as an edge case versus regular operation? And what are the scenarios or the different things that we need to build more competence in? And as people the projects are getting started, the teams at the beginning have a very ambitious goal of like, yeah, we want to understand everything and we want to do everything, but then there is a trade-off between accuracy and cost. If you're going to label every single point in every single data that you've ever collected, it just takes time and effort. And then how do you deal with bugs? Bugs, it could be hardware issues, like at the sensor level, or it could be at the system level. It could be at the software that is doing the data collection, or it could be even the software that is doing the visualization, like our tool. We're not perfect. And the humans who do the labeling are also not perfect. So how do you engineer the best process that takes into consideration these complex tools handling the complex data, and then empowering the humans who are very disciplined and very methodical in their approach, but put them in a process that enables them to be very productive, where the tool is actually assisting and giving the human superpowers in how fast they can process the data, rather than getting in the way and slowing them down. Typically with customers, we see that the first couple of months is a lot of mutual learning. Like, we're getting to understand the data, we're getting to understand what is the taxonomy, what are we trying to accomplish, how do we codify these rules in the tools, and how do we train the workforce to understand and really focus on the metrics and the aspects that the customer cares about. And then how do we bring autonomy in a more thoughtful way? So because once we understand kind of what are we trying to do, why we're trying to do it, and what the customer cares about, then we can start the optimization process. And getting from that initial like 0 to 1 journey, it can be fast in some cases. There are many customers, I won't name names, that like have been doing this for a long time, and they come ready, they know exactly what they want from day one. And there are a lot of other customers that are kind of, yeah, we're deploying these sensors for the first time, let's see what we can do. And we've done, at Deepen and iMerit, we've all worked with the likes of Neuro and Cruise and Waymo and others that are that have been actually like developed significant in-house IP to deal with these problems. And then there are many others that did not spend as much time in collecting and understanding the data. Actually, even some of these customers have their own sensors. So it's there's a wide spectrum of focus and specialization, as well as interest in the level of expertise that they want to have in-house. Even like, does it even make sense for, say, a company that is a tier 1 supplier that is reselling other people's LiDARs to develop these kind of capabilities? And ultimately, the way we partner is to allow them to not go and invest the same level of investment that Waymo has done in LiDAR and tooling, maybe hundreds of engineers for 3-5 years, and enable them to get going from day one using a specialized workforce and specialized tooling. Maybe this would have been a longer answer than what you wanted, but we've been trying to cover all the angles here.
Cool. I really liked how you phrased the platform has the goal of giving humans superpowers and not getting in the way, and so that you can get the best of both capabilities. That's a nice way of thinking about it. And you've certainly brought up a lot of interesting issues in deployment. Fault tolerance of the hardware, for example. You can't afford to have the car break down or malfunction if a sensor malfunctions, which can happen pretty frequently out in the field across millions of cars. That's a very interesting topic. What I found most interesting is the insights into best practices that you shared, the ability to anticipate from past experiences what kind of problems in labeling, classification, prediction might come up, and thereby being able to help newer players to define their processes better when working with us. I think that's at the core of it. Not having to reinvent the wheel each time, understanding the best way to use both the human experts as well as the software in a kind of a updated manner, so that you sidestep a lot of problems that happened in the past. I think this is the evolutionary method that makes complete sense to have specialists in this field focused on it and working with multiple customers, which is what you do and which is what we do. I think my kind of last major question to you would be, what do you see as a state of the art of LiDAR today? And what are some of the more exciting capabilities you think might come up in the next few years that will take this field even much further ahead?
Yeah, the most exciting stuff in LiDAR now is that it's in production. The sensors from Argo, from Waymo, from Velodyne, Luminar, Ava, IBO, Vallejo, etc. I don't want to take sides. We like all the LiDAR companies, and they're all doing a great job. But the LiDARs are real, and the cost or the efficiency, the economies of scale are coming together to bring the cost down, and the threshold of quality is being met. So we've seen like Luminar and Volvo, they're being deployed. We've seen like Plus AI using Ava that was announced recently. And obviously, there's a lot of Velodyne deployments across all types of use cases, not just in automotive, but in construction, in mining, in agriculture, and so on. And we know like companies like Quanergy are focusing on security and observation for malls and airports and things like that. So, and we've worked with all of these types of LiDARs. The different technologies within each LiDAR segment are also getting specialized. So we know for trucking, for example, you care about longer range. So you want to see much farther ahead than urban level 4 type deployments. We know in like in agriculture use cases, maybe short range is all you care about, but you want to have a very accurate, like what are the apples on the tree, you know, versus the leaves, and you want to avoid the big rocks, and you know, maybe one LiDAR is more than enough for that use case. You don't need 4 or 5 LiDARs like what you do in a level 4 autonomous vehicle that has to be running in the streets of San Francisco, like, you know, what Zoox and Cruise are doing, and even Waymo now. So it's yeah, there's a lot going on in the perception side of LiDARs, on the hardware side, and on the software side. You know, the work we're doing on calibration is evolving very quickly and adding to the safety stack and the ability to deploy. And maybe one area that we're also seeing evolve, like the detection, segmentation, tracking, and prediction quality has gotten to a point where it's good enough for a lot of cases. So the level of conversation is getting elevated to how do we deal with scenarios? Like, we're not now just talking about detecting humans and cars. We're now talking about higher order combination of things that we need to be aware of. You know, what if a dog runs at a certain speed coming from behind a vehicle that is totally occluded, and how do we deal with these situations? And so this is where we get closer to safety certification, and that's where we think is the next frontier in the ability to utilize LiDARs in a lot more use case driven way. That's where the economies, like the economics will come in. People coming at the mall, how many people can you count out of everybody that has really entered the mall, or how many people exited? What are their behavior, you know, for security and airport use cases? If there is a bag left in the middle, is that bag like really was dropped by mistake, or was there a malicious person that dropped the bag intentionally? And these
Right.
higher order understanding of what's going on is really the next frontier. We call it scenarios, by the way.
I think scenarios are and then those scenarios can get pretty complex. You can get into simulations and start to look at very complex interlinked events where if there's a crash ahead of you, how should you respond? How are all the other cars going to respond on the freeway? A lot of these come very instinctively to humans. I think the challenge is to codify it for automobiles based on the inputs they're receiving and combination of inputs they're receiving. So that's a very exciting future. I like what you said also about the other fields like geospatial. We're definitely seeing a lot more drone deployment with LiDAR to inspect assets from the air and to try to analyze. And that is possibly even more taxing because of the huge data loads, since a drone's field of view is massive compared to a ground level automobile. You and I have certainly worked on point cloud sizes in the hundreds of millions of points in those use cases. I think the trade-off is really good. The advanced complexity and data density of LiDAR versus the nuance that it gives you to cover the last mile of perception, I think is a good equation. And I'm very excited about some of these insights that you've provided today. give us a good sense of where things are going to head and what are going to be the new questions asked from us as a solution, as experts in the field, and sounds really exciting. I guess my last non-serious question is, when you go to sleep, do you dream of point clouds at night?
Sometimes, especially those colored, like beautiful, everything is classified down to the millimeter.
Oh yeah. Okay. So thanks a lot, Mo. This has been extremely informative. I thought I knew a fair bit about LiDAR, but I think you added some real dimensions today. And again, thanks for coming on, and thanks for our partnership. I think our customers have a lot to be excited about in hearing what you spoke about today. And all the best.
Yeah, thanks, Jay. We're excited about the next phase and looking forward to collaborating further.